Depending on who you ask, the term climate change can mean different things. To some, it means lower crop yields, the spread of disease, and rising sea levels. For others, it harbors the end of a diverse ocean. Numbers on a graph can only tell you so much about what is threatening today's fish species. You may know that global temperatures and CO2 levels are rising, but with that comes changes in weather patterns. Extreme storms and an increase in hurricane activity are all possible, even though weather and climate differ.
So weather are atmospheric phenomena that occur on hourly and daily timescales, while climate's atmospheric phenomena that occur on either yearly, sometimes seasonally, and more decadal scales, so longer timescales.
Extreme weather has the ability to destroy fish habitat and make it harder for fish larvae to settle.
Thinking about hurricane activity, that is up for debate right now. There's conflicting studies that say that hurricanes can potentially become more frequent, they could potentially become less frequent, but there is consensus right now saying that hurricanes are actually going to become more intense in a future climate. The thing about climate change is that it's just based on a radiation balance where we're heating up the atmosphere. So the Earth, to stay in radiation balance, it's basically going to emit. It'll just go back to whatever balance it needs to be in, whether that's at the level of where it is now or if that's 10 degrees higher.
Some fish are unable to tolerate a wide range of temperatures, including the Atlantic cod. They prefer an average temperature between 0 and 12 degrees Celsius. Cod are historically overfished, but commercial fishing isn't the only thing contributing to their decline. Rising temperatures are forcing the cod to move north of Georgia's bank, which is further affecting their population.
So how has climate change affected ocean pH? We've been noticing basically since the end of the 1990s and the early 2000s that something is going off and that there is a constant drift down of pH. So what is happening is that pH in our oceans and in our coastal oceans is changing basically because we are emitting carbon dioxide, and that makes the ocean more acidic. The term ocean acidification does not mean that the oceans are currently acidic. The pH of the ocean is about 8.1 right now. It has been decreasing. How a lower pH of the ocean is affecting marine organisms, particularly fish. Fish do not form external calcified skeletons, but the larval fish, the tiny larval fish, might have a problem and might get compromised by high CO2 levels, low pH levels.
Studies have shown that the commercially important species yellowfin tuna are susceptible to ocean acidification. The survival rate of tuna larvae decreased after 7 days in water with a lower pH.
The questions that we need to answer is how the effect on fish is then mitigated or altered in the entire food web, how an entire ecosystem might change, how fish stocks might change, and it does not only depend on fish but also on the other trophic levels like copepods or phytoplankton.
For systems that are controlled through bottom-up processes, the transfer of energy is incredibly inefficient. This means that when one organism eats another, the energy contained in that prey organism is lost to the environment. For example, if you went to an all-you-can-eat buffet and you gorged yourself on 10 pounds of food, the net effect would not be to actually gain 10 pounds of food. While you might feel awful about yourself, you're only going to gain maybe 0.1 pounds of food at most. This is because oncologists use the back of the envelope calculation of roughly 10% transfer efficiency. This means that 90% of the energy is lost to the environment.
But what does this mean for apex predators such as sharks? It means that if the rate of primary production is altered by climate change, it could reach the upper levels of the trophic system. Sharks like these blacktips rely on fish like anchovies to survive, and anchovies rely on plankton.
Every time we see the biomass of these apex predators, we have to realize the majority of energy to get there was actually lost to the environment.
A large amount of research still needs to be done.
Fish are definitely part of the puzzle.
And we're already seeing plenty of evidence for this occurring in the global oceans.
We're not trying to save the planet, we're trying to preserve it in the state that it's in.